All right, so yesterday we looked at area and consecutive integers within our word problems. Today we're looking at projectile motion problems. So those are things that are getting kicked into the air, that is being launched. If you've ever thrown a ball super high and you've seen it take that like arch into the air and then come down, it's a projectile motion. So looking at number one, a soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. So we want to pay attention to that 90 feet per second because that feet per second tells us our variables here, right? So that feet depends on our seconds. So that is our y, is our feet, and our x is our seconds. So that's important to note so that way we understand what we're looking for on our graph. So we are going to use Desmos just like we have been. So we are looking for the maximum height of the ball. So that is going to be our vertex. So then what we'll do here is we'll go over to Desmos and we'll type in our equation that we are given. So the equation is h equals negative 16t squared plus 90t. So as you can see, it starts down here at 0, like we are kicking that soccer ball up, and we need to find the maximum height of the ball. So we're going to go ahead, drag this up all the way. So we've got 2.8125 comma 126.5625. So we are looking for the feet. So if we have 2.8125, that is our seconds, and we have 126.625. So that means that y value is our height of the ball. So our max height is 126.5625 feet. Okay? How many seconds will it take for the ball to reach the ground? So now we are looking back, thinking about that 0, our x-axis is the ground, right? So picture your graph as you are standing on the ground, you kicked it here, and it's coming back down to reach the ground here. And again, our x is our second, so when we look at that 5.625, it's going to take that many seconds for it to hit the ground. Okay? So let's look at the next one. An apple is launched directly upward at 64 feet per second. So again, feet per second. Our y is our feet. Our x is our seconds. So they are on an 80-foot platform. The equation for this apple's height, h at time t seconds after launch, is h equals negative 16t squared. So our equation is very similar. We're going to change that to plus 64t plus 80. Okay? The maximum height of the apple, again, we are looking for our vertex. So we're going to go over to our graph. we've got to reach all the way up to that maximum height. So we have 2,144. So we're looking for height, so we need our feet here. So we have 2,144. So it's going to be 144 feet. How many seconds will it take for the apple to reach the ground? So I'm going to go ahead and hit that little home button on my graph. And it's going to take, if I've got 5, 0. So when it reaches the ground like that, it's looking for our zeros or our x-intercept. So we have that 5, 0, so it's going to take 5 seconds. Okay. I want you to try now number 3. So pause it, try number 3, and I'm going to check that in tomorrow. Let's go ahead and look at number 4. So a penny is dropped off the Empire State Building, which is 1,250 feet tall. If the penny's pathway can be modeled by the equation h equals -16t squared plus 1,250, how long would it take the penny to strike a 6-foot tall person? So what we're going to do with this, so that h represents our height and the t represents our time, right? So we are given a 6-foot tall person, so that is our height. So when I have my equation here, I'm going to go ahead and substitute in when I plug that into decimals. So I'm going to have 6 equals negative, oops, forgot my negative, negative 16t squared plus 1250. I am going to get an error, so let's go ahead and change this t to an x. So when we are looking for a time, we cannot have a negative amount of time. So we're going to go ahead and we are not going to worry about that negative 8.8. We're just going to worry about that 8.8176. So that means that my time is 8. So it's going to take that many seconds for a penny to strike a 6-foot tall person. Okay, so let's look at number 5. Some fireworks are fired vertically into the air from the ground at an initial speed of 80 feet per second. The equation for this object's height, h, at time t seconds after the launch is h equals negative 16t squared plus 80t. How long will it take the fireworks to reach the ground? So reaching the ground is that 0 feet, right? So that's going to be our x-intercept. So we don't have to adjust our equation at all. So we're going to go ahead and put in our new h equals negative 16t squared plus 80t. Okay, so fireworks are fired up vertically, so I can almost picture it going up, and then when it comes back to the ground, it will take 5 seconds. Because we get that 5, 0. So I want you to try number 6 and 7, and it'll be checked in tomorrow. So pay attention to what the question is asking for and what you need to replace. 6 is looking for your maximum height. So remember, that is your vertex. And then 7 is giving you a height. So you are going to need to replace that within your equation. Okay? Give it your best try.